Hello and welcome to a new episode. Today I am again at a local scrapyard, sifting through piles of trash to look for items that this society has discarded, but that might still be interesting for us who are willing to learn, repair, reuse, or repurpose. And I'm mainly looking for tools, but I'm always interested in other things as well. So let's see what we can find here today. Now just look at this gigantic motor here. It appears to be a pump, and I'm sure that you could have a lot of fun playing around with this. But it might be a little too heavy for my purposes, as many things that I can find here. And this looks like an old TIG welder, a water-cooled TIG welder. We have both the welder as well as the water cooler in separate enclosures, but they are in really bad shape. I think this is too far gone, even for someone as crazy as me. But today we actually find a lot of decent stock material here, and I will buy a bunch of this steel here for later projects. And look at this old filing cabinet, US property. Gotta wonder how this made its way to this random scrapyard here in Germany. And here we have a big old vise. But I already had vices in two of my most recent videos, and this one's also in a pretty poor shape, as far as I can tell. Now this compressor here looks salvageable, and I say that's a keeper. Here is an old vacuum cleaner that I also found at the scrapyard. But it's not just any old vacuum cleaner, but a professional level machine by the German company Sebo. And a comparable new model is around 400 euros. And since I really don't like the quality of most vacuum cleaners I see in stores these days, I figured that this one might be worth repairing. The motor obviously starts, but you can hear some unhealthy sounds coming from inside the enclosure. A burnt smell is in the air almost immediately as well. In order to get inside the enclosure, I first have to unscrew a bunch of screws and kind of pry off this rubber part here. It's now rather simple to remove and disconnect the old motor. Just by trying to move the impeller here in the front of the motor, I can already tell that it is sitting way too loosely and that the bearing is probably damaged. After unscrewing the motor brushes, I can access two more screws that hold the motor together. Here we can see that the bearing is almost falling apart, hanging by a thread. And now that I have pulled out the armature to see if that has any additional damages, the bearing has literally fallen apart. Pulling off the bearing and fitting a new one on the shaft could turn out to be very hard, but as luck would have it, replacement motors are available online for around 40 euros. And I ordered one right away because I think that this cleaner is worth it. The rubber dampener is fitted on the new motor and it is connected electrically as well. And then the enclosure is put back together. And after this rather simple repair, the vacuum cleaner works just fine. Let's take a closer look at the compressor then. The first thing I do is to remove this plastic hood and the discharge tube. The tube was only connected on one side because the check valve or one-way valve normally connecting it to the tank is missing. Malfunctioning check valves are very common. Maybe the former owner could not find a replacement part. The nameplate says that this is just a perfect tool. What a humble statement. It's an ordinary, probably Chinese-made 24-liter compressor though. The power rating is 1.1 kilowatts. This compressor is nothing special really. And as much as I love repairing high-quality German-made gear, This channel and this format is all about doing the principal thing, repairing, reusing, repurposing, even if it might not always make commercial sense under the current conditions. Now is the time though where you can learn to repair things by training with cheap discarded gear. Who knows what the future will be like? I don't know if cheap labor and abundance of energy and resources will be with us forever. Since one of the wheels is broken, I will just remove them both for good. It'll be a stationary compressor for the time being. And I proceed to clean the tank, also in order to inspect the surfaces further. And there's a lot of dried motor oil residue outside of the crankcase. Maybe there has been an issue with one of the gaskets, but maybe the compressor just kinda spilled because it was tipped over during its transport to the scrapyard. This is the inlet port of the compressor, and there is a piece of plastic tube in here, and this is what's left of the old air filter that has obviously snapped off at some point. The plastic enclosure of the pressure switch is also broken. I'm now temporarily installing a quick connector into the inlet of the tank where normally the check valve is installed, and I'm using my stationary shop compressor to test this tank. I don't recommend to do this, but I just need to find out if the tank itself was damaged before going through the hassle of repairing all the different damages that I already found. The external compressor here in my shop is pressurizing the tank to 8 bars. And you can hear the pressure switch of our little compressor here clicking. The gauges, regulator and outlet also seem to work just fine. The wires connecting to the pressure switch though are very brittle. They need to be replaced as well. And I'm proceeding by taking off the cylinder head. Since the air filter had broken off, dirt and debris was allowed to enter through the inlet port, potentially entering the cylinder. These thin metal springs form the inlet and discharge valves. They are contaminated by dirt and what appears to be insect larvae and will need to be cleaned. And I have to pry off this steel plate, damaging the gasket below in order to remove all the earth and dirt inside the inlet port, where a bunch of insects have apparently decided to build their nest a while ago. This piece also has some serious rust on it, and that rust has to be removed. And I proceed to take the cylinder further apart, only to find even more dirt that has to be cleaned out. In order to take the cylinder apart entirely, I will first drain the old oil though. I could probably just unscrew the oil plug gauge for that, but since I want to look inside, I decided to just remove the entire back of the crankcase and drain the motor oil that way. And inside the case I find dirt as well. Among other things, I'm using brake cleaner to clean this as well. And since there is dried oil all around it, I can't be sure if the lower gasket here is actually holding tight, and therefore I will renew that as well. With the piston removed, I can check if the motor is actually still working. I renew the wiring and connect the motor to the mains. It runs just fine, but because of the imbalance in the load, strong vibrations are to be expected. And now I use some new gasket paper to produce 3 replacement gaskets. Measurements are taken and the shapes are simply drawn onto the paper. Then I use an ordinary knife to make new gaskets and install them in the different spots in the cylinder. In the next steps, the cylinder head is reattached, the crankcase closed and filled with new oil. and we can perform a first primitive test to see if the compressor works in principle. Next, the old pressure switch is unscrewed. The gauge, regulator and safety valve are then removed from the switch, only to be reinstalled on the new pressure switch, which in turn was already screwed back onto the tank. So at this point, the only important part that was still missing was the check valve. I ordered a pretty cheap replacement part online. It fits inside the tank inlet and can be connected to the unloader line, but the port for the discharge tube is on the wrong side and has the wrong size. But I simply couldn't find the correct replacement valve, and I also didn't want to spend even more on this repair, so I went for a rather unusual solution. I simply wanted to lead a copper tube around the valve, connecting to the discharge line, and I solved the problem as follows. I sifted through all the brass parts I could find on my shelves and picked this 90-degree angle here. I opened the valve and temporarily removed the parts that would be heat sensitive. Then I screwed the valve and this angle piece together, but also just soldered the threads together so that the two parts would keep this exact orientation and still be airtight. And then I added a few more fittings until I was able to connect the discharge tube to the check valve. I then connected the valve to the unloader line, waited for everything to cool down and put the valve back together. Normally, lines for pressured air should be braced, not soldered. And I don't recommend this approach in general. It was just a desperate last-ditch repair. I then proceeded by adding a new air filter that I had also bought for a few euros, and now it was time for a test. So, at least for the time being, the compressor seems to work just fine. Time will tell though if these repairs are any good. And I just want you to keep in mind that these videos are not necessarily about doing a perfect job all the time, but about just starting to do things, even if you make mistakes sometimes, because otherwise you just won't learn how to solve real-life problems. Here is another goodie that I found, and I'm pretty sure that many of you won't recognize right away what this actually is. Upon closer inspection, we can find an old nameplate of the German company Siemens, and it still has the old logo comprised of an S and an H, and that was short for Siemens und Halske, and this particular logo seems to have been used between 1936 and 1973. By the looks of it, I would say that this part is at least from the early 1960s though. When we type in the numbers from the nameplate, we can find pictures of what this actually is and what it once looked like. It is a signal or alarm horn, and it is missing its rather iconic cone. After unscrewing the bolts, we can open the cast iron enclosure. Inside, we find an old rubber gasket and an actually very well preserved buzzer that is based on a simple solenoid or electromagnet that can be powered from the mains electricity directly. I renew the electrical connections and close the housing and clean it from the outside. It needs a new horn or trumpet, and for that I need some steel sheets. And normally I would order these online or hop into my car and buy some, but there is a cool new thing here in Cologne since last year that I can totally get behind. Electrical cargo bikes that anyone can rent for a few euros an hour. So I drove to a local hardware store that is specialized in metal stock parts of all kinds, bought a sheet and loaded it into the cargo bike and drove to the shop. For transporting mid-sized cargo like this in a crowded city, the cargo bike can actually be more convenient than using a car, in my opinion. So, measurements are taken and a roughly triangular shape is drawn onto the sheets. Then an angle grinder is used to cut it into shape. A primitive method is used to bend the 1 mm thick steel sheet into a roughly cone-shaped form. And now, the little vise that I repaired in the last episode is used to hold the cone together until it is properly welded together. After cutting off the tip, a flange is made from the remaining sheet material, and flange and cone are welded together as well. Now the new horn is painted and left to dry before it is bolted onto the old enclosure. So does it work? And if yes, what does it sound like? So guys, you know the drill. If you liked this video, then please give it a like so that I know that there is demand for more. And you can also support this channel if you visit my Patreon under patreon.com/tpai. See you soon.